Hello, how are you? I'm the Amateur Logician from amateurlogician.com, and I hope you are doing well. In the previous video, we worked on some mathematical proofs that were direct proofs with the textbook Basic Mathematics by Lang. This time we're going to work through some mathematical proofs via contraposition and via contradiction. Now, by contraposition or by contrapositive, we should recall that the proposition if P then Q is logically equivalent to if not Q, then not P. A proof of this structure, of this form, if P then Q, is a so-called direct proof. A proof of this form, if not Q, then not P, is a contrapositive proof. Consider the proposition, if A is even, then A squared is even. What would the contrapositive of that be? It would be, if A squared is odd, then A is odd. Since this proposition is logically equivalent to this proposition, it's perfectly legitimate to prove if not Q, then not P, to thereby say that if P, then Q happens to be the case. And recall, a proof by contradiction is where we make an assumption. That assumption we show is false by deriving from it an absurdity, a contradiction. We can also do something called induction, but we'll save that for a future video. So, okay, we want to prove that if n squared is even, then n is even. Doing a direct proof is not so straightforward there, but a contrapositive will work. But first off, we better recall some key points in basic number theory. So remember, an even number would include 0, 2, 4, 6, and so on and so forth. It has the form 2n, where n is really some natural number, including the number 0, by the way, in this case. An odd number would be something like 1, 3, 5, 7, etc. And it has the form 2n plus 1. And again, n is some natural number, including 0. One of the cool things about mathematics is that we can think about the general form, the general structure of some pattern. Or in other words, we can say that n is even if n is equal to 2k. We can say that n is odd if n is equal to 2k plus 1. That's another way we can think about it. So we want to prove if n squared is even, then n is even. Like I said, a direct proof would be quite difficult, but let's try a proof by contrapositive. So we have if not Q, then not P. Or in other words, if n is not even but odd, then n squared is not even but is odd. So we're going to assume n is equal to 2k plus 1, i.e. it's odd. And then let's just square it and do some mathematics. So we have n squared. That would equal 2k plus 1, quantity squared. What would that equal? It would equal 4k squared plus 4k plus 1. So let's work with this expression here. We can rewrite that as 2 parentheses 2k squared plus 2k, close parentheses, plus 1. And if you stare at that, that has an odd form. Or in other words, think of it as 2 times, let's say, b plus 1, where b represents that 2k squared plus 2k. This has an odd form. So that's definitely odd. So thus, n squared is odd. So we prove that if not q, then not p, but that's the same thing logically as saying if p, then q. Hence, it does follow that if n squared is even, then n is even. And by the way, we could intuitively verify that. For instance, let's say we have something like 4 squared, which equals 16. Well, note that 16 is even, and note that 4 is even. But we just show that pattern holds all the time because we're looking at the general structure, the general form of all even numbers, which is pretty cool. Now let's do our second example, and this time we're doing a proof by contradiction. So we're going to prove that the square root of 2 is irrational. In other words, or i.e., that is, it's not a rational number as a fraction. Okay, we're going to do a proof by contradiction. So we're going to assume the contradictory of what we want to prove. So we're not going to assume that square root of 2 is irrational. We're going to assume that the square root of 2 is rational. And we're going to be led to a contradiction, and because of that, that assumption must be false, or in other words, the square root of 2 is indeed irrational. So the square root of 2 is equal to a over b, where a and b have no common factors. And let's just do some mathematics here. Let's utilize our algebraic skills and just square both sides. So we'll say square root of 2 is equal to a over b. We'll square the left-hand side and, of course, the right-hand side. And from there, we get 2 is equal to a squared over b squared. We can then multiply the left-hand side and the right-hand side by b squared. So we can get 2b squared is equal to a squared. Or by a symmetric principle, we can re-express this, move the left-hand side to the right-hand side and the right-hand side to the left-hand side to say that a squared is equal to 2b squared. This implies that a squared is even. Moreover, note that in our last proof, we saw that a must be even as well. So if a squared is even, then a is even. And remember, see last proof on that. So we can say that a is equal to 2k because it's even. So that's an important note. So let's then say, remember, we have 2b squared is equal to a squared. We can re-express that. 2b squared is equal to the quantity 2k squared. That right-hand side, of course, is 4k squared. So now we have 2b squared is equal to 4k squared. Let's just solve for b squared. Divide both sides of the equation by 2. So b squared is equal to 2k squared. But that implies that b squared is even. And that implies that b is even. So we can say that b is equal to 2r because it's even. That's an important note. But note here, a is even. A is equal to 2k. B is even. B is equal to 2r. But we have a common factor of 2. So, but then, we have a common factor of 2. Hence, we have a contradiction. And because of that contradiction, thus, the square root of 2 is not rational. In other words, it's irrational. So we have just proved that the square root of 2 is irrational by a proof by contradiction, and we have also proved that if n squared is even, then n is even by a proof by the contrapositive or contraposition. I'm the Amateur Logician from amateurlogician.com. Thanks for watching. Good luck to you and be well.